Okay, so this video should talk to us a little bit about the binomial CDF and the binomial PDF. Now, I made an error right off the bat. This should be the binomial PDF, and there's my dog Charlie again. So, binomial PDF. It's a function on our calculator, and where we find it is we turn on our calculator and we press second function and vars for distribution. And you'll see that there's a whole bunch of different types of distributions here, PDFs and CDFs. And binomial PDF, binomial CDF are options A and B. Now you can scroll down to get to them, or you can scroll up. So I'm gonna go back, second function, vars, and if I scroll up, I can get to binomial PDF and binomial CDF there as well. Okay, so before I get to that point though, I actually need to do some calculations and read the question. So the question, what are the chances I cut the deck 6 times and on 3 of those attempts, I cut a face card? Seriously though, what are the chances? Well, I suppose the first thing we need to do is decide, is this a binomial experiment? Well, I have a specific number of trials. I have either a success or a failure. That success is cutting a face card, and failure is not cutting a face card. And because I'm not removing that card, the probability of success and failure doesn't change each time I make the cut. So I'm going to say that this is binomial. I'm going to let my random variable x be the number of face cards. Number of face cards. Okay. Now, x is going to be distributed binomially, and we've already said that there are 6 trials, and now we need to calculate the probability of success. So, kind of off to the side here, I'll start counting probability of success. So, how many face cards are there? Well, there's the king, there's the queen, and there's the jack, and there's 4 suits, so that's 12 face cards, and there's 52 cards in a deck. So that means that there's 12 over 52. But of course, I don't really need those 4 suits because it's the same for all 4 of them, so that's going to be like a common factor in each of those numbers. So each of those numbers is going to be divisible by 4, and then that's true. So I end up with my probability of success being equal to 3 over 13. So that is my distribution of x. Now I don't need to make a distribution chart. I don't need to show all of the possible probabilities for 1, 2, 3, 4, 5, and 6 because I'm just asked for the chances of 3 attempts. So 3 attempts, attempt, that's a funny spelling mistake. Attempts has a T. So what I actually need to calculate is the probability that big X is equal to 3. Now, when you see this equal sign here, this tells you you're going to use a PDF because you're looking for an exact probability. If you were looking for a range of probabilities, that's when you would use a CDF. So we're going to go ahead and use binomial PDF here, and I'll show you what the wizard looks like. So we'll do second function, vars, and I'll scroll up to binomial PDF. It's option A. Now the number of trials is 6. The probability of success is 3 over 13. And I can type this in as a fraction using my alpha y equals, or I could just do 3 divided by 13. My x value is my number of successes, and paste is going to give me my answer. Now it'll paste my answer in for this expression. So that's the syntax for typing in the expression if you want to type it by hand. And it looks like I have a probability of 0.111875. Or, to 3 significant figures, there's an 11.2% chance of that happening. So if I did this 10 times, if I did this whole experiment 10 times, I would expect to have 3, I guess a little over 1 time. But this is a binomial PDF example and how to use it on your calculator. I hope it was helpful.